So again, hello. In this video, I'm looking at trigonometry. We have already completed three videos on coordinate geometry. First two were on the revision notes for coordinate geometry, and the third one being the problems of coordinate geometry. If you have not seen that, then please have a look at those three videos too. This section is on trigonometry. I'm only handling the how we look at identities that are to be proven. So before I go to the identities that we have to prove, let me just go through a brief overview of the trigonometry. You first are looking at a right angle triangle. Consider a right angle triangle in which the right angle is Q and you have the other two angles as P and R. So first and foremost, sine theta, sine of any angle is defined as the opposite side divided by the hypotenuse. And cos theta is defined as the adjacent side divided by the hypotenuse. So if I'm looking at P as my angle, that is if I want to find out what is sine of P, then the opposite side will be QR divided by the hypotenuse is going to be PR. So it is QR upon PR. But if I change the angle, that is instead of P, if I'm going to look at R, then sine R will be, the definition remains the same. But because the angle has changed, sine R will be opposite side, that is QP divided by PR. QP divided by PR. Let's look at cos of an angle. Cos of P. Cos of P is adjacent side by hypotenuse. So for angle P, the adjacent side is QP and the hypotenuse is the same, that is PR. But when I say cos R, cos of R, for R, the adjacent side is going to be QR divided by PR. Remember, sine square theta plus cos square theta is equal to 1 is very simple. Why? Is because when I am taking a right angle triangle, you know that this square plus this square is equal to PR square. That is QP square plus QR square is equal to PR square. So that is QP square plus QP square plus QR square, and I add these two, I'll get is equal to PR square upon PR square, which is equal to 1. I have written this over here only because you already know all this and I have not actually derived this identity. This is all something that you know by now, and this is just a revision note. So this is only for our recapitulation, that is sine square theta plus cos square theta is equal to 1. So now, having understood sine theta and cos theta, let us take tan theta and cot theta. Tan theta is going to be the ratio of sine theta upon cos theta. So what happens is this hypotenuse gets cancelled and I will get opposite side divided by the adjacent side. And cot is the reciprocal of tan theta. So I get tan theta is equal to 1 upon cot theta, or tan theta into cot theta is equal to 1. Cosec is the reciprocal of sine, that is hypotenuse divided by opposite side, and sec is going to be the reciprocal of cos, which will mean that hypotenuse divided by the adjacent side. Before you sit down to solve, there are a few things you must remember. That is, one is these are the identities, that is sine square theta plus cos square theta is equal to 1. 1 plus tan square theta is equal to secant square theta. 1 plus cot square theta is equal to cosec square theta. Then if you remember in the previous slide, we did tan theta into cot theta is equal to 1 because tan and cot are reciprocals of each other. Sine and cosec are reciprocal, therefore sine theta and cosec theta is equal to 1. Sec and cos are reciprocal, therefore sec theta into cos theta is equal to 1. You also need to remember, along with all these trigonometric identities, you should also be able to recollect all the algebraic identities, which is a plus b whole square, a minus b whole square, a plus b whole cube, what is a square minus b square, all these algebraic identities also you need to remember. So let's get started with the first identity that we will be, first identity. This one is prove that 1 plus, I've started with the simplest questions. So the first simple one is prove that 1 plus sin A upon 1 minus sin A is equal to cosec A plus 1 upon cosec A minus 1. Remember, in these identities, you can start from left hand side and arrive at the right hand side. You can start from right hand side and arrive at the left hand side. You can do any way, any method. So let's start with LHS. When I am taking LHS, 1 plus sin A upon 1 minus sin A, you should keep looking at your right hand side. What is it that I want to prove? So you can see this is sine and this is cosec, which means that if I convert this sine to cosec, that is, you know, sine is the reciprocal of cosec. So I'm writing down sine as 1 upon cosec, and in the denominator this sine is 1 upon cosec. Now I will take the LCM. So this will become cosec A plus 1 divided by cosec A and cosec A minus 1 divided by cosec A. This cosec and this cosec get cancelled, and therefore I'm getting the right hand side. This is my right hand side. If I'm starting from the right hand side, I'm writing this right hand side, and now I'm saying that I have cosec and I want sine. So I'm writing this cosec as 1 upon sine, 1 upon sine, and then when I take LCM, I will get my LHS. Clear? Let's go to the next one. Here we have to prove that tan A minus cot A is equal to 1 minus 2 cos square A upon sin A cos A. So I'm starting first from the left hand side. LHS is tan A minus cot A. I'm writing sin A upon cos A upon sin A. I take the LCM. So this becomes sin square A upon minus cos square A divided by sin A cos A. Now when I come over here, I see that my denominator is the same. But when I look at the numerator, here it is 1 minus 2 cos square A, but over here it is sin square A. That means I want to convert this sin square into cos square. So I'm writing down sin square as 1 minus cos square A. You already know this. Cos square A plus sin square A is equal to 1. So my sin square A, I'm writing it as 1 minus cos square A. 1 minus cos square A. That will become 1 minus 2 cos square A. So you have got the numerator and the denominator as it is over here. So it's done. Suppose I decide to start from RHS. That is 1 minus 2 cos square A upon sin A cos A. What I am going to do now is this 2 cos square A, I am splitting it as minus cos square A minus cos square A. And now this 1 minus cos square A becomes sin square A. So I am getting sin square A minus cos square A. This will now, because my denominator is only one value, I will separate it like this, and I got tan A minus cot A. This sin square A over here gets cancelled with sin A, cos square A gets cancelled with sin A. I am left with sin A divided by cos A, that is tan A, and cos A divided by, this should have been, cos A divided by cos A. So this will become cos A upon sin A. This will become cot A. Now, in every question, it's not going to be very easy for us to do every question is not going to be very easy for us to go from left hand side to right hand side to left hand side. We need to be a little observant, read the question properly, and then decide whether you want to start from left hand side or you want to start from right hand side. In this question, I think that it is much easier for me to go from LHS to RHS. So I'm writing down the sine to the power 4a minus cos to the power 4a as sine square a whole square minus cos square a whole square. Then I am going to use the formula, that is a square minus b square is equal to a minus b into a plus b. This will give me sine square a minus cos square a into sine square a plus cos square a. But sine square a plus cos square a is equal to 1, whereas this is this one. Now again you look at my RHS. If you look at your RHS, you are getting 2 sine square a minus 1. So I want to get rid of this cos square a. So I'm writing it as 1 minus sine square a. So you need to write over here, because you know cos square a plus sine square a is equal to 1. Which identity are you using? You need to keep writing that. So this is the identity that we have used, and therefore we get is equal to RHS. Okay, this question, fourth question, cosec A minus sin A in one bracket multiplied by sec A minus cos A, third bracket is tan A plus cot A is equal to 1. Obviously, I cannot, I will find it very, very difficult to start from RHS. I will obviously go from LHS. So, I'm writing this cosec as 1 upon, I'm writing cosec as 1 upon sine minus sine, sec as 1 upon cos. I'm leaving this for now. This will give me 1 minus sine square a, 1 minus cos square a. But 1 minus sine square a is equal to cos square a, and 1 minus cos square a is sine square a. So when I do the multiplication over here, you can see that this is a multiplication. This cos a is getting cancelled with this cos, and so this cos a gets cancelled with this cos, and this sine a gets cancelled with this sine. I'm getting cos a into sine a. And now when I take the tan a plus cot a, I will write it as sine a upon cos a plus cos a upon sine a. Then take the LCM, I'm getting this numerator will become 1, and this sine a, this numerator is becoming 1, and this sine a cos a will get cancelled, and I get is equal to RHS. Hence proved. Okay. Fifth question. Prove that sec a minus tan a upon sec a plus tan a is equal to 1 minus 2 secant a tan a plus 2 tan square a. Now this looks very scary, but if you look at it properly and if you observe it properly, the right hand side, if you see the right hand side, it is saying 1 minus 2 secant a tan a plus 2 tan square a. That doesn't it tell you something of the type, it is of the type a plus b whole square is equal to, this formula is something like a plus b whole square. Because of this, sorry, it should be a minus b whole square. So it tells us something about a minus b whole square. That means I have to convert this. This is 2 secant a tan a. 2 secant a tan a. I am having tan square a, but I want secant square a. So what I did was, I am having one I have tan square a. This 2 secant a tan a. If I want to convert it into a minus b whole square, I need one sec square a and I need one tan square a. I have 2 tan square a's. So what I did is I'm splitting the tan square, 2 tan square as tan square plus tan square. Now this is becoming 1 plus tan square, that will give me sec square, and this is 2 secant a tan a, and this is tan square a. So that was giving me secant a minus tan a whole square. Wonderful. Now let's see, keep looking at what you want to prove. So my LHS is saying there is secant a minus tan a, I have got 2 times, but in the denominator I want secant a plus tan a. So what I do is I am multiplying and dividing by secant a plus tan a. When I do that, I will keep this secant a plus tan a, and from here one of them I am keeping them over here, and let me see what happens to the remaining. That means secant a minus tan a into secant a plus tan a. This is going to become a minus b into a plus b. So this is a formula, that is a minus b into a plus b is equal to a square minus b square over here. And I also need to write down over here the identity that I have used, that is 1 plus tan square A is equal to secant square A. So here I'm getting a square minus b cube. But you know secant square A minus tan square A is equal to 1 because 1 plus tan square A is equal to secant square A, which implies this part will be equal to, this part will become 1. So I've got this is equal to LHS because this is into 1. This part is going to become 1. Okay. Now this one sin A plus cosec A whole square plus cos A plus secant A whole square is equal to 7 plus tan square A plus cot square A. I am starting from the left hand side. This I'm expanding it. I'm using the formula that we know, that is A plus B whole square is equal to A square plus 2AB plus b square. So I get sin square a plus 2 sin a secant a cosec a. Now you know the sine and cosec are reciprocals of each other. So when this 2 gets cancelled, these 2 get cancelled and I'm left with only 2 over here. So this 2. In the same way over here, these 2 get cancelled and I will get 2. I'll get the other 2. In the same way, I'll also get sin square a plus cos square a is equal to 1. So I've got this one. And I'm left with cosec square a plus secant square a. So the identities that we are using over here are going to be, we will say sin a into cosec a is equal to 1. Cos A into secant A is equal to 1, and I'm also using sin square A plus cos square A is equal to 1. These are the 3 things that I'm using over here, actually 4, including the identity. So this part will give me 5, and here cosec square A, but I want tan square. I'm not interested in cosec and sec. I want tan and cot. So I'm converting this cosec square A as 1 plus cot square a and sec square a as 1 plus tan square a. That was going to give me 7 plus tan square a plus cot square a. Now I can actually try going from RHS also. So I am writing down, obviously going from LHS is the easier route. But just suppose I want to try going from RHS for your curiosity. So 7 plus tan square a plus cot square a. Since everything is in terms of cosec and sec, so I am splitting this as 5 plus 1 plus tan square, 1 plus cot square. And this 5 I am splitting it as 1 plus 2 plus 2. This 1 plus tan square becomes secant square, 1 plus cot square will become cosec square. This 1 can be written as sin square a plus cos square a. And I am now putting them together, and this 2 will become sine into cosec and this 2 will become sec into cos, and therefore I am getting this is equal to LHS. Sine theta proved that sine theta minus 2 sine cube theta divided by 2 cos cube theta minus cos theta. Obviously, the first thing that we did when we learned factorization in the 7th and the 8th standard was anything that comes out common, take out common. So from here in the numerator, sine theta comes out common, and from the denominator, cos theta comes out common. And I'm left with in the numerator 1 minus 2 sine square theta, and denominator is 2 cos square theta minus 1. This part is giving me tan theta. My right hand side is tan theta, which means that it should give you a hint that this has to get cancelled. So what we do, this sine square theta, we will write, you know that it is cos square theta plus sine square theta is equal to 1. So in sine square theta, I am substituting it as 1 minus cos square theta. So that is when I expand it, 1 minus 2 plus 2 cos square theta, this will become 2 cos square theta minus 1. 2 cos square theta minus 1. So this gets cancelled, and these two get cancelled, and you will get is equal to RHS. Simple. This is one specific type of question which generally children get confused. What should I multiply? Everybody knows that you have to multiply and divide by something, but multiply and divide by what? So you have to look at what is there on your right hand side. Right hand side is saying secant A plus tan A. Tell me, secant A means 1 upon cos A and tan A means sin A upon cos A, which means my denominator has to be cos. If I want my denominator to be cos, that means inside the square root, I must have 1 minus sine square. So everything is going reverse direction. Your thinking has to go reverse. From this side, you're going this side. So what I do, if I divide by 1 plus sine A upon 1 plus sine A, this is going to be 1 plus sine A into 1 plus sine A in the numerator, and denominator will be 1 minus sine A into 1 plus sine A. That will give you cos square A. When I take the square root, this will go and I will get 1 plus sine A upon cos A. That will be 1 upon cos A plus sin A upon cos A, that is secant A plus tan A. You have to keep looking at what is there on the right hand side. What do I have to arrive at? So to continue with that, I'm just giving you this example to make you understand how I am thinking about it. So here you have got square root of 1 minus cos A upon 1 plus cos A is equal to sin A upon 1 plus cos A. In the denominator, I have got 1 plus cos A. So I am multiplying and dividing by 1 plus cos A because 1 plus cos A into 1 plus cos A will give me 1 plus cos A whole square, and when I take the square root, I will get only 1 plus cos A. Also, in the numerator, 1 minus cos A into 1 plus cos A will give me 1 minus cos square A, which will give me sin square A, and when I take the square root, I will get only sin A. That is what I have on the right hand side. So I told you, I repeat, you have to keep looking at what do you want to prove, and accordingly you must be going about. My next video will be on the complementary angles section of trigonometry.